Hello all. Got on the bench today is the Eico model 174A single tracer. This is the one that Mike from Mike's Radio Repair sent in to us, and I thought we'd go ahead and do a little work on it today and get this up and running. Now one of the biggest reasons I like to get this working is to use it on our 101 project, because the 101 has a noisy component inside of it somewhere. When it's sitting there receiving, you can hear some crashes and static and different noise in the radio that I have not been able to locate. With a single tracer, this will help us find or locate the whereabouts of that noisy component. Now, a lot of people think that, you know, a single tracer is only used on old tube radios. Well, that's not true. You can use a single tracer on any radio, solid state, anything that has audio RF path, you can use a single tracer on. And when I first got this, I did go ahead and plug it in, and I noticed as I plugged it in and turned it on, there's a slight hum in it, and the hum gets a little more pronounced as you turn the gain up. Also, when you turn the gain up past 12 o'clock, the speaker starts to howl, so there's something feeding back into the circuit. This is probably due to old capacitors and probably some resistors out of tolerance. So we're going to get into this thing and take a look at it and see if we can't get it up and working like it should be. Now, I'm not going to do a restore on this, because this is not going to be a piece of equipment that's going to sit on the shelf and not be used. This is going to be a working piece of equipment. So only thing I did was wiped it down, cleaned all the dust off of it, and I may take the knobs off later and polish them. But you know, I wiped the front down, got all the protective film off of it, as Mike would say, and we'll go ahead and pull it apart and get in there and see if we find out what's going on. Now, anytime I get a new piece of old tester gear, first thing I do is go on the internet, find the manual, and download it. And not thinking, when I did this, I just typed in, you know, Eico 147A single tracer, and downloaded the first manual I come across. And I didn't realize, but the one I had downloaded is the model 147. There's no A designator on it, and the difference is the 147 is a 5-tube tracer, and the 147A is a 4-tube tracer. So, you know, theoretically everything works the same way. It's just that the schematics are not the same. A lot of stuff is, yes, but it's not the direct schematic. So from there it was back to the internet and searching again, and I actually found the 147A schematic. Could not find a manual, but at least I did find the schematic, and I found this on CB Tricks. Under radios, select E, go down to Eico, and they got a section in there for some Eico test equipment. So I do have a schematic, I just don't have a manual for it, which that's quite fine, because you know, you can refer back to the 147A manual, and that'll help you along through it. So when working on an old piece of equipment like this, the first thing I do is pull the tubes out of it and set them aside so they don't get damaged. It's very easy. If you knock it over, you know, you can damage the tube. I have checked all the tubes, and the tubes are checking fine. So the first order of business is going to be this capacitor here. Now, this is a 4-section can capacitor. It has 240 and 220 and 210 microfarad capacitors at 450 volts inside of this can. Now, we could take our capacitors and go in here and put some terminal strips and mount them underneath, but I want to kind of get into restuffing the capacitor if the capacitors will fit in here, and we'll go through that process and see just how hard it'll be to do that. I went ahead and removed the capacitor, and all I did was, there was 3 wires actually going to it and 2 resistors going to it, and I left the other 3 resistors mounted on the bottom of the can. And depending on how this capacitor opens up will determine if I leave these resistors on or not. Now, some capacitors, I can't quite tell on this one, where they normally have a aluminum shell and they're crimped over onto a steel ring. Some capacitors just have a complete ring on it, and it's just completely molded around, and these are not aluminum, some type of metal alloy, a light steel. And the problem with these, if you try to open the can up, most of the time it cracks and the legs break off, so that steel is a little bit brittle. Now the capacitors that has the dual part on them, you can already see where I had started working on this one, and all I do is heat this bottom of the capacitor up about an inch at a time with my hot air gun, and then I can come in and start prying this back until I can release this steel ring. Once this is completely opened up, I just hold it here with a pair of pliers, take a hot air gun, heat the whole body, put an oven mitt on, and slide it out. A lot of times these things are parted with a bit of tar that holds everything in place. So after looking at this capacitor real good, you can see the steel ring here on the inside, and you can see the crease around there. So this is the aluminum that's pressed in over on the steel ring. So we can open this cap up, and then we have to see if we have enough room inside to mount our 4 capacitors. Now if your capacitor is a 1-piece capacitor, you can always come around this lip and cut it off with a Dremel tool or a hacksaw. Just cutting far enough in, heat it up, and then you can slide the old capacitor out, and you can see the tar that's on that and a little bit of tar inside. And we'll take some acetone and clean this out. This is actually for another piece of equipment, and this capacitor is completely gone, but I wanted to put it back, and restuff it. It's only 1 capacitor in this. Now if you have a lathe, the best way to do this is chuck this up in a lathe and take a very small parting tool and cut it, and that'll give you a nice good straight cut. So you can see the idea here is, once you get it started, is get a little screwdriver under and just start working your way around. Now it takes a bit of time to do this. You're not going to do it in no big hurry, so just take your time. And I get it started with a very small point. Just kind of get in there and find a place that you can get it in, and hammer it under a little bit, and you start prying it up enough to get the width of a old screwdriver into it. Now as you can see, I went around the whole capacitor and got that lip opened up. So now the next thing we need to do, oops, drop my pliers. Let's get in here and just straighten this lip out. And this will take a little bit of time. Just go around it, flatten that lip out, And this way our ring will slide out without any problem. I really like to restuff the capacitors because it keeps your equipment in a original looking state, but there's nothing at all wrong with going underneath and mounting capacitors under it. That is perfectly fine and is a well known acceptable state. Now you see I have the ring is loose, but it's not coming off, and that is because there is actually a ground wire from the internal capacitors that is connected to this ring. So I'll have to get in there and cut that loose so I can remove that ring. And there you can see that ground strap that is connected to it. It does pull up just a little bit, and it's simply just grabbing it and break it, twist it right off, because that's no longer going to be used. So now I can get the ring off, and we'll heat this body up and pull this right out. Okay, and there I have the ring completely off. Now I'm going to do this outside because the smell of heating tar is not that good, and you know, you don't want to be breathing that stuff. So I'm going to carry this outside, and I'm going to grab my big commercial heat gun, and I'm going to hold this side with a pliers and heat this up real good, and that way that'll loosen up the tar from around the body, and then I can slide this cover right off, exposing the inside. And there we go. And you see after heating it, I'm able to slide it right out. Can's still a little warm, even though it's set out there a little bit. You can see inside of it all that gunk that's left in it. So I have to clean that out. I'm going to do that by heating it again and taking a old screwdriver and scraping it out in the bottom, and then clean the inside of the can. Then what we'll need to do is dig all this stuff off around the bottom of the base and get the old capacitors off. But that's the inside look. See, there's a ground strap. So I'll go ahead and get all that done. So I left this so you could kind of see what was going on inside. As you can see, there's 4 strips of aluminum come up, and each one of those strips has a piece of foil connected to it, and it's just rolled up in a diameter. And there in the bottom of the trash can, you can see all the foil and the insulating material, and it was pretty much dried out. There wasn't much left to it. So the next thing we got to do, we cannot solder to this because this is aluminum. I've got to remove this base, and what I'm going to do is clip these off and remove this base and go up so I can get down to, well, I guess you can't see it, could you? But I got to clip these off, pull the base up so I can get down to something to solder to. So as you see, I did not clip those leads off flush. Now these terminals are steel, and the aluminum leads go in beside it and just crimp to the terminals. Now the reason why I left these long is so I could bend them over, and this gives that terminal a little more support. So if we look at our diagram on our can, we can see that the two 20 microfarad capacitors connects to the half circle and the square, our 10 microfarad capacitors connect to the triangle, and this one shows no designator, and that'll be marked on the bottom as no designator. So if we look here, we can see that there's a triangle here, there's a square here, there's a half circle here, and the last terminal has nothing. So our two 10 mics will go between the triangle and the one that has no designator, and the other 20 mics will go to these two terminals. Now, the biggest thing I'm worried about is enough room inside this capacitor to house them. So it looks like if I mount the two 20 mics side by side, I can get one 10 mic beside it like this and get them glued in place, and the other 10 microfarad capacitor can actually sit flat across the top of these. So we'll work on that theory and see how that goes. So I really had my doubts if this was going to work or not. So basically you can see we have the two 20s and one 10 microfarad capacitor. And that's in a triangle shape. So if we look at our can, we mark that to the top, we can see we should have plenty enough room. This can should slide right over it, and those capacitors will slide right up in there. Now, you know, I still have to do a insulating all the terminals so nothing can short out on the can or short against each other. But when we get our 10 mic on, we'll have a fourth wire coming down. So we should be able to slide this onto this and solder directly to our terminals. So here's basically how our capacitor stack is going to look. I have all 5 leads coming out. I've got to trim the insulation off. This is the positive side of the top 10 microfarad cap. And we'll wrap all this in tape to keep anything from shorting out. Now I went ahead and took the bottom and I drilled a hole all the way through at each leg, and I decided what I wanted to do this time is bring the legs out and solder them to the terminals on this side of the mount, and then I'll bring the ground out over here on the side so it can be connected to the ring. So our capacitor's all put together, and all I want to do now is just take some hot snot and go around the bottom of it. That'll hold everything in place, and you know, it'll also act as an insulator for the leads, and we can slide it back in our can. Now I did put a mark on the can, and there's also a mark here on this lead, so this needs to line up with those two marks, and it'll put the can orientation back in the original position that it was once in. Okay, I did want to also mention, before you put everything in the can and lock it down, is to check and make sure you got no shorts. I don't have a problem with that myself, but you know, you just want to make sure that nothing is shorted, and you can just test from your leads. Most time you wouldn't have the resistors on it, but you know, just want to make sure nothing is shorted. I got the mounting ring in there and also had a mark on it, and that put everything back in its original orientation. So the only thing left to do now is crimp the ends of the can back down. Well, our capacitor's all put back together. Got it all crimped back in. So all we got to do is clean up the holes where it was soldered on the chassis and get it mounted back in. So I got our capacitor mounted back in, and what I'm doing now is going through checking resistors. And I checked all the resistors when I had the capacitor out, this, you know, on the capacitor. This way this didn't have to desolder any of the resistors from the terminals, since the top of the cam had been cut off. And all those checked good. Well, going on through, and here on V2 pin 2, which is a 6AQ5, there's a 330 ohm resistor going to ground from pin 2, and I've checked it. Now this is supposed to be 330 ohms, and it's checking 406K. So that resistor is all but opened up completely. So I'm going to have to find a replacement for this one. So looking here at the schematic, we can see V2, and that's pin 2, which is the cathode, and this brought the ground through R9, which is our 330 ohm resistor. So the way this is, the cathode is completely running open. It's not even being grounded through the resistor. So we'll have to go ahead and replace that. Alright, I got a Eico 174A single tracer back together, and everything's checking out on it pretty good. So just for a demonstration, I was telling you we had some noise in our receiver. Let me turn the tone off, we don't need that. I'll turn the volume up on our FT101. You can hear that noise in the background. I haven't been able to locate that. So I'm going to use our single tracer. So what I'm going to do is plug the RF board up here. And that's our input. It's fairly quiet. That's from our RF gain pot. And that's our output. And you can see, you can hear that noise on the output. Alright, I'm going to probe a few points here on the radio, and we'll listen to our input and our output. This is the input from our single generator going into the board, and it sounds fairly normal. And we'll listen to the output. Now you can hear some of that noise riding on the output, but you know what is causing it. Well, I'll go ahead to the RF gain input onto the board, and it's fairly quiet. But if I monitor the AGC coming in, listen to that. That is where our noise is coming from. So there's something in the AGC circuit. Is either a broken lead on a capacitor, or you know, a component failing. But there's definitely something on the AGC that's causing this erratic noise in our $10 101. So as you can see, not every repair is a tough repair. Some of them are very simple. A broken input switch, bad capacitors in our metal can capacitor, and a bad 330 ohm resistor was all it takes to get this piece of equipment up and running. This piece is already in decent shape to start with, and all it needed was just a little cleaning, which I have done, and it's looking real good. So I might go ahead and put some polish on this old gray paint, and even though it was clean, you know, and scrubbed pretty good, put a little shine back to it. And the only other thing I want to do is change this cabling to a good double shielded cable. And I'm even going to leave this old connector on here. I'm not going to change it. I do have an adapter that goes from this to B and C if I need to use a B and C on it. So I'm going to leave this just like it is. And I hope you enjoyed the video. Like I say, it wasn't much. It didn't take long. I probably spent an hour and a half on this thing. And as you can see, it, you know, just some of them is not that hard to get in and get going. Again, you know, I had something good to work with to start with. So anyway, hope you enjoyed the video. I'll leave a link down below to the schematic on this. And also, you know, I post all my videos on my website. So if anybody wants to jump on the website and discuss the video, the link is always down below. And, you know, if you like the video, let me know. And we'll catch you in the next one. Thanks now.